Hey, Algebra 1. So we introduced a few different ideas today on some of the things we've kind of already been talking about. Took maybe a step in the more advanced direction, I would say. And so let's walk through some homework. Today we talked about function notation, two different types of notation. When is it input, that's this top one, and when is it output, and that's this bottom one. So today we talked about how finding the value that goes in to make an outcome isn't bad as long as you understand how to set the problem up. So 17 is not the input, we're actually looking for the value to plug in that makes 17 come out. So once I set it equal, I'm going to add 5 to the other side. That gives me 22 equal to 2n, and then you can divide by 2 to see that 11 is the value of input that's going to create 17. So if you think about it, 2 times 11 is 22, minus 5 does make 17 as an outcome. So I want you to try these, and I'll give you a hint. One of them is input, and one of them is output. So see if you can figure out which one is which, give it your best shot, and then we'll check our work tomorrow. Just look back at the other ones if you had any questions about which one is which. So email me also if you also get stuck. We're coming a little bit early. We'll talk about it before class starts. So we talked about how to create equations that match certain graphs, and first you got to figure out if you think it's linear or not. So the first thing we talked about is how you can study the behavior of each side to understand if it's linear or not. And so this one's actually pretty straightforward. You are adding 4 on the right for the y values, you're adding 2 for the x values, and so that's pretty consistent every single time. So this is a linear graph. It also is really nice in telling us the y-intercept value. So whenever x is 0, the other value creates the b term or the intercept term that you are using whenever you're creating the equation. Okay? So in this problem, we can find the rate of change by saying if the right side is going up by 4 and the left side is going up by 2, so I just picked 2 points to do the slope formula. And so 8 minus 4, that's that 4 that we said on the right. 4 minus 2, that's the 2 that we see on the left. So this has a slope of 2. So whenever I'm going to create my equation, I can say, well, y equals 2x. And then that y-intercept is 0 from the table. So we really don't even need to write that. So we can take a moment to check to see that all the input-output works. For example, if you were to do 6 times 2, well, that is 12. Or if you were to do 4 times 2, well, that would be 8. And so all of those values work just like that. So let's look at another one. This one seems to be adding 2, adding 2, adding 2 over and over and over for the input values. And on the right, this seems to be going down 6, down 6, down 6. Now, if you have trouble seeing that, what we're trying to calculate is the slope. So similar to what I did in the first problem, I'm just going to pick 2 values and do the slope formula. The slope formula is y2 minus y1. So I took the second y and subtracted the first y. And then I'm going to divide by the other one, -1 minus -3. So 4 minus 10 is -6. And -1 minus -3, that kind of changes to a +3. And -1 plus 3 is 2. So it looks like these are dividing to be a slope of -3. So that's important at first to figure out what your slope is. So I know this is y equals -3x. But I can't just grab the y-intercept from the table because it's not there. I could maybe figure it out based on some number patterns, but right now I don't really have it to figure out. So what I want to do is I'm going to pick a point and say if you were to replace y with, for example, -8, and I was going to replace x with 3, well, what number would I need in the back to really make all this work out mathematically? So 3 and -3 multiply to be -9, and so I really need that to calculate -8. So I'm going to add the 9 over, solving for b, and that number is a 1. So I'm going to go back and kind of replace b with the number 1 So y equals negative 3x plus 1. I want to double check that that works, so I'm going to pick maybe a different point. 1 is supposed to give me negative 2. So negative 3 times 1, that's negative 3. But if you add 1, you do in fact get negative 2. So that formula seems to be working pretty well. So why don't you go ahead and try the next two tables, and we'll check your work tomorrow. And the next part is trying to calculate slope, which I've actually been demonstrating several times in this video so far. I know I'm erasing some of the work, so you can kind of go back and watch it again if you need to, or be more than happy to answer any question tomorrow if you felt like you didn't quite understand. So I'm going to start by saying, well, y2 minus y1, negative 5 minus 7. And in the bottom, I need to do negative 7 minus 8. So negative 5 minus 12 is, or negative 5 minus 7 is negative 12. Negative 7 minus 8 is negative 15. And so not only are these both negative and they divide to be positive, but 12 over 15 reduces to 4/5. If you're not sure how to reduce, I'll bring that back to our brain. 12 and 15 have a factor of 3. So if I divide both of these by 3, that's how I'm getting 4/5. So you try this one, and we'll check your work tomorrow. Number 3, let's start by trying to get y by itself. So I'm going to minus 9 to the other side. 2y equals negative 9x plus 10. And then I'm going to divide the 2 into both values, solving it literally for y. And so this is going to be our equation that we need to graph. So this is our b, or our y-intercept value, meaning that I'm going to go find 5 and plot that point on the y-axis. And then this is my slope, and that is telling me to go down negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 2. And so there is your line. So I like checking my work as I go. I think that makes things a lot more doable, and it makes me feel more confident that I did it correctly before I move on. It's not like I just guessed at this work. I can stop and find mistakes by checking my work. So what we talked about today is the x value should go into the equation and calculate the y value. So negative 9 halves times 2 plus 5. So yesterday I tried to teach you guys about why this rise over run works the way that it does. And it's because if this number is a 2, well, every other number is going to cancel out really well when you calculate it. Negative 9 plus 5 is negative 4, and so I know that that point truly is on that line, so I think I'm doing well to get that correct. You try number 4, and let's look at number 5. You're going to do number 6. And so if I'm trying to build an mx plus b, the b value is always this value that hits the y-axis line, and that seems to be negative 2. So I know that at y equals, the back number should be a minus 2. Now the slope can be calculated by thinking about the rise over run. From this point that's at the bottom left to the other point that's in the top right, it looks like it goes up 1, 2, 3, and over 1. Well, 3 divided by 1 is 3, so I'm pretty sure that this is 3x minus 2. Now if I want to know that that's correct, if I want to know that's correct, I'm going to pick one of the points and just verify that if you plug in the x value at that point, it calculates the y value at that point. So this is the point 1, 1. 3 times 1 is 3, minus 2 is in fact 1. So that does work correctly. So I know my equation is good to go. You try number 6. And so number 7, this is the last one I'll do. We're trying to write an equation that goes through these 2 points. So there's kind of 2 steps. The first thing we need to know is what is the slope. And once we know the slope, we can use that in what's called the point slope formula to calculate a line that would go through both points. So y2 minus y1 divided by x2 minus x1. And so this looks like I'm getting negative 2 over negative 1, which calculates to be 2. Now, this is where several of us just stopped on the homework last night. This is not complete. This is y minus y1. I'll just pick 0 because that's going to make this a little faster. 2 times x minus x1, again, 0. And so y minus 0 is just y. And if I distribute, I just get 2x, and there's my equation. So if you plug in 0, 2 times 0 is 0, so that point's there. And if you plug in 1, 1 times 2 is 2, so that point is also on that line. Good luck. I hope this video was helpful, and I will see you tomorrow.